Welcome to physics class. My name is Gias Uddin. My dear students, today we are going to discuss about another important topic, difference between classical mechanics and quantum mechanics. Difference between classical mechanics and quantum mechanics. As you noted, classical mechanics is the branch of physics which deals macroscopic object at very low speed. And also we know that quantum mechanics is the branch of physics which deals microscopic object at higher speed. Okay, so we are going to discuss about introduction of classical mechanics and quantum mechanics. Classical mechanics. Classical mechanics is the branch of physics which deals with macroscopic object at low speed. It means that in classical mechanics, considered the speed of object is very less than speed of light. This is also known as Newtonian physics or Newtonian mechanics. So this is the introduction of classical mechanics. Now we are going to discuss about quantum mechanics. Quantum mechanics is the branch of physics which deals with microscopic object at high speed. It means that in quantum mechanics, the speed of the object in quantum mechanics considered the speed of object is nearly equal to speed of light. This is also known as modern physics. Okay, so this is the introduction of classical mechanics and quantum mechanics. Classical mechanics is the branch of physics which deals with macroscopic object at low speed. Okay, it means that in classical mechanics considered the speed of object is very less than the speed of the light, and this is also known as Newtonian physics or Newtonian mechanics. On the other hand, quantum mechanics is the branch of physics which deals with microscopic object at high speed, and it means that in quantum mechanics considered the speed of the object is nearly equal to the speed of the light, and this is also known as modern physics. So this is the introduction of the classical mechanics and quantum mechanics. Now we are going to discuss about distinguish between classical mechanics or quantum mechanics, or we can say that difference between classical mechanics or quantum mechanics. Okay. Now our first difference between classical mechanics and quantum mechanics. Number one, classical mechanics is the branch of physics which deals macroscopic objects like vehicle, star, football, etc. So these objects is called macroscopic object. On other hand, quantum mechanics is the branch of physics which deals microscopic objects like electron, proton, neutron, etc. So this is the first difference between classical mechanics and quantum mechanics. Classical mechanics is the branch of physics which deals macroscopic object like vehicle, football, star, etc. And quantum mechanics is the branch of physics which deals microscopic object like electron, proton, neutron, etc. Okay. Now second difference between them. Classical mechanics based on Newton laws of motion. So this is called Newtonian mechanics. On other hand, quantum mechanics based on Schrödinger wave equation that is so this is Schrödinger wave equation. Our first difference is classical mechanics is the branch of physics which deals macroscopic object. Macroscopic object means very big object, large object. Say suppose vehicle, star, football, aeroplane, galaxy, all are macroscopic object. But quantum mechanics is the branch of physics which deals always microscopic object like electron, proton, neutron, etc. Okay. And second difference, classical mechanics based on Newton's laws of motion. We know that Newton's first law, Newton's second law, Newton's third law, and gravitation law. So classical mechanics based on Newton's laws of motion. So this is called Newtonian mechanics. But on other hand, quantum mechanics based on Schrödinger wave equation. This is called Schrödinger wave equation. Okay. And now third difference between classical mechanics and quantum mechanics. Classical mechanics deals with with certainties. On other hand, quantum mechanics deals with probabilities. So this is the third difference between classical mechanics and quantum mechanics. Number 4 difference. Classical mechanics explains to classical mechanics fails to explains suppose photoelectric effect, Compton effect, Raman effect, and energy matter relation. Heisenberg uncertainty, principle. Okay, but quantum mechanics successfully explain photoelectric effect, Compton effect, Raman effect, energy matter relation, and Heisenberg uncertainty. Principle. So this is the number 4 difference between classical mechanics and quantum mechanics. This is number 4. Classical mechanics fails to explain Compton effect, Raman effect, photoelectric effect, and energy matter relation and Heisenberg uncertainty principle. On the other hand, quantum mechanics successfully explain those effects, say photoelectric effect, Compton effect, Raman effect, energy matter relation, and Heisenberg uncertainty principle. Now we are going to discuss number 5 difference between classical mechanics and quantum mechanics. Classical mechanics based on particle nature of object, On other hand, quantum mechanics based on dual nature of object, that is particle and wave, and wave nature of object. Okay. We know that classical mechanics based on particle nature of object and quantum mechanics based on dual nature of object. Okay. Now last difference between classical mechanics and quantum mechanics. In classical mechanics, future state of particle we can completely determine if initial position of particle is known. Okay, in classical mechanics, future state of particle we can completely determine if initial position of particle is known, but in the case of quantum mechanics this is impossible. In quantum mechanics, future state of particle we cannot determine, we cannot completely determine there is always some uncertainty. In classical mechanics, this is the last difference between classical mechanics and quantum mechanics. In classical mechanics, future state of particle we can completely determine if initial position of particle is known. So suppose this is x direction, x coordinate, and an object initial position, this object displacement is initial position, this is a x. Okay, after sometimes its velocity we can write dx by dt, and momentum also p equal m into b, so we can write m into dx by dt. So if initial state is given, then final state we can completely determine. In this is only valid for classical mechanics, but quantum mechanics this is not possible. It means that this is impossible. Okay, thank you.